So we just computed the MLE for linear regression, and I want to briefly, so we did it in the special case where we were considering, you know, just the identity. We weren't thinking about a basis function. So way back up here, we were using this sort of model, and we weren't using any basis functions. So this is really, it's not only linear in W, which is the linear part of linear regression, it's also linear in the x's. And if you, so I mentioned in another video that you can model nonlinearities with linear regression, nonlinearities in the x's, by using basis functions. And I want to just, make explicit how that works here, just to let you know what it looks like. So remember, when we were using basis functions, we had we were considering functions of the form W transpose phi of x, where phi, this phi here, was a function from Rd, from x's, to Rm, I think I said m, for some integer m. And we observed that by making like a little change of variable, essentially, let z equal phi of x, then this is just, of course, W transpose z. And you can do all of this same stuff, just replacing, so this whole argument that I did above, everything goes through with z if you just replaced all the x's by z's. And so in that case, what everything looks like, so this was our solution to the MLE, and so the y's are unaffected when we use basis functions, but the a's, remember, the a's have x's. There's x's going on in the a's. Where's a? Oh, there's a. All right, so this was a. This was this design matrix thing. It was x1 transpose, blah, 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 xn transpose. And this is going to become, so phi of x I transpose is going to replace these rows. So back down here. So the design matrix in this, when we're using basis functions, let's write it with a different letter. Let's write, so sometimes people put like a capital phi. For the matrix, phi x1 transpose, so that's the first row, down to phi of xn transpose. So it's just, it's just z1 transpose to zn transpose. That's all. And then, right, and so this is now, it's n by m. So the dimension here could be changing. And by, according to the comment, as I observed, we can just replace the x's by z's. So the A matrix just gets replaced by the phi matrix, and that's our new design matrix. So this solution here, A transpose A inverse times A transpose Y. So the solution for this type of, if we're assuming a linear regression model using these basis functions, then it would be, we have to choose, the basis functions that we're going to use, but then it would just be this thing, phi transpose phi inverse phi transpose y. Or easier to write, it's the pseudo-inverse. Pseudo-inverse of phi times y. And that's it. I mean, that's the only, everything else, all the argument above, everything goes through just fine. And and this is how you can model nonlinearities in the x's. So I should mention, I made this assumption, and I guess I didn't point it out at the end. We were assuming here that the columns of A are linearly independent. So I should have mentioned here, this is assuming columns of A are linearly independent. And the same thing down here. So that's the MLE in that case. Columns of phi are linearly independent. Okay, so that's the MLE. We got it.